Welcome back to the Scotti-BYTE channel, and this is Scott. Today we're going to talk about workstations in your home lab. So it is valuable for the self-hosting environment to have a minimum of 2 desktop computers. Desktops, unlike laptops, provide more expansion for multiple hard drives, Ethernet adapters, and supplementary I/O devices, which may be valuable in debugging and testing other functions. So one of these desktop workstations should have a minimal tools configuration and be in your home lab and have proximity to your router or switch infrastructure for testing and problem solving. In this video, I'm going to discuss some changes I made to my 2 main desktops. So, my 2 main systems are, first of all, I have many systems, but I want to focus on my daily driver desktop and my home lab desktop system. My personal daily use desktop is named Mondo, and it is a Dell XPS 8930. It has a Core Intel i7-8700 with 6 cores and 12 threads running at 3.2 gigahertz with 32 gigs of RAM running Ubuntu 2004 LTS. My home lab desktop, which I call Putter Room because I putter around in there, is an AMD A8 5600 with 4 cores running at 3.6 gigahertz with 8 gigs of RAM, and it dual boots Ubuntu 2004 LTS and Windows 10. So this machine is an older machine. It was I built it on a generic platform back in 2012. So I want to do some disk drive updates, and I'm going to talk a little bit about my journey here. So we're going to talk about how I perform what I would call a rolling disk drive update. That is that I moved a disk drive from one system to another and repurposed it. So Mondo was running a 1 terabyte Samsung 970 EVO NVMe drive. Good drive, but I was at the point where I was running out of space on occasion, and I wanted some high performance disk. I do have some spinning drive on that same machine, but I still wanted some high performance space. So Putter Room was running on a 500 gigabyte Western Digital VelociRaptor, which is a 10,000 RPM drive released in 2013. And at the time it was a real barn burner, but now with current software, it just seems to run pretty slow. So I'm going to show how I migrated Mondo to a 2 terabyte Samsung 980 Pro NVMe, and I realize that that's a PCI Express 4 drive, and my machine is only a PCI Express 3. However, I'm doing that for futures. So I'm also going to show how I migrated Putter Room to the 1 terabyte Samsung 970 EVO NVMe drive that came off of Mondo. So the hardware for the Mondo transition is I put the 980 NVMe drive into a Sovereign USB 3.2 Type-C enclosure. And that's what it looks like. So I bought this off of Amazon, and basically you can put an NVMe drive in there. You might want to note that there's a difference in these enclosures whether you're using an NVMe drive or an M.2 SATA drive. They have a different key and they work differently. So then I also added an Initech PCI Express X4 USB 3.2 Gen 2 expansion card to Mondo, and that's got 6 USB Type A's and 2 USB Type C ports. And the reason that I added this was because I had 2 external USB hubs, and it was just kind of a wiring mess, so I wanted to kind of straighten everything out, and I decided to put this card in. So what's the hardware for Putter Room? Well, I purchased an inexpensive $12 NVMe PCI Express 3.0 X4 adapter, which I installed into its only PCI Express slot, which interestingly was an X16 slot. It was actually the video card slot for that machine. but it's a micro ATX machine, and I'm actually using the motherboard-based graphics because I don't have any particular reason to want high-performance video on that machine. So there's the little $12 add-in card. It's a PCI Express card, and it can handle my NVMe drive. So then the next thing that I did is there's a command called smartctl. If you haven't seen it before, it's basically a query tool to query the smart statistics on various drives. In order to install it in Linux, you do a sudo apt install smartmon tools. And after you do that, we've got the installation, and we're going to use it later on in this video. So then I wanted to image the old Mondo drive. So to do that, I was going to use DD, and the input file was going to be /dev/NVMe0N1, which is the specification for the NVMe drive, the 970, and then an OF output file equal to /dev/std, and that external enclosure showed up as drive std. And I put a status equal progress just so we can watch and see how it performs. So here's the drive clone. Initially, I was going to install PV to watch for statistics. PV is a program that lets you pipe statistics for a drive copy. But instead, I just decided to do a status equal progress. So here I have sudo dd, and I've got the command above. And so, interestingly enough, this ended up taking about just in excess of 20 hours. So I'm really kind of questioning whether or not that enclosure, the 3.2 enclosure, was actually operating at speed. It sure looks like it wasn't. So anyway, here's what the drive looked like after it was cloned. Basically, the Mondo desktop system was using a 1 terabyte space. So there's the 1 terabyte partition on the 1 terabyte space, which used to fill the old drive. And then we have a large unallocated section after that. So I removed the 980 Pro from the USB enclosure, and I replaced the 970 EVO into in the motherboard NVMe slot with the newly cloned 980 Pro. And then here, we're booting up Mondo, and we went ahead and did a smart control -I on /dev/NVMe0N1. And you can see that now it's the Samsung SSD 980 Pro 2 terabyte. So that all worked. Booted up, everything worked fine. However, there were some post-installation steps I needed to take on Mondo. One of them was that I went into gparted and I had to correct the ending logical block, since the DD command makes an exact clone and it was reporting the drive size of the new 2 terabyte drive basically as 1 terabyte because that was the ending block from the clone. So when you enter gparted, it'll give you an option to fix that, and that's what I did. So I could have expanded the partition to the full 2 terabytes, but I'm going to leave it free because I might install another OS on the new partition in the unused space. On a new partition in the unused space, basically. Okay, so what do we do with Putter Room? Well, we installed the old Mondo 970 EVO onto the NVMe to PCI Express 3.0 X4 adapter, and we installed it in Putter Room. So this is what the adapter looks like. There's the 1 terabyte NVMe drive that we took from Mondo, and we installed it on this card. And here it is in Putter Room. Putter Room's a very old system, and we've got it installed in the X16 slot. So you can always install a, like an X4 in this case, into an X16 slot. It just doesn't use the additional pinouts. So it has fewer lanes. Okay, So here's the actual drive copy on Putter Room, and I thought this was quite interesting. In the upper left-hand corner, I first did a date, and you can see that it was 6:51 UTC when I started, and I did a DD of SDA. So SDA would have been the VelociRaptor drive that was in that in Putter Room, and then the output file was the NVMe drive, which was /dev/NVMe 0 and 1. And by the way, for both of these clones, both the clone on Mondo and this one on Putter Room, I booted up a Windows, not Windows. I booted up a Ubuntu Live drive just not to have anything locked at the time that I did it. So actually, all these backups are actually done from an Ubuntu Live, and that's why you can see here this option to install Ubuntu. So you boot up an Ubuntu ISO either from a USB or a CD, and then select the Try Ubuntu option, and it brings you into a live version of Ubuntu. So anyway, I thought it was interesting, but that this clone took 90 minutes to perform, and I thought, wow, that's really great. That's the kind of performance I was expecting. And basically, we had probably, I don't know, I think it was like 385 gigabytes used. But as I pointed out earlier, DD is even going to copy the blank logical blocks. So it had to do the entire 500 gigabytes. So then here in the bottom left, I have the Smart Control-I on the SDA, which was the Western Digital VelociRaptor. You can see it calls up Western Digital VelociRaptor, and it calls out that it's a 500 gigabyte drive. And then in the lower right here, I did a sudo smart control on the NVMe drive, and it calls it out as the 970 EVO at 1 terabyte, and it did that. In the upper right hand corner here, we've got an instance of gparted running, and this instance of gparted was actually before the clone. And what we're looking at here is the way this drive used to look like in Mondo, in that it had one giant partition here, other than the EFI partition, and that was its data partition. We mounted the ext4's root, which is real typical for setting up like a default Ubuntu, default Linux in general, unless you build a more complex file structure. So then over here it calls out the fact that there is in fact a /dev NVMe 0 and 1, which was the terabyte drive. SDA is the VelociRaptor at 500 gigabytes. And then finally down here I have an SDB, which is actually a USB thumb drive that was 32 gigabytes, and it's plugged in. We're going to see in a moment why I have that plugged in. So then I took my cell phone out and I did a screenshot, which is why this looks so horrible. But basically, I went into the BIOS of Putter Room and took a look at it, and this is the boot order, or boot order options potentially. And if you look down this list, you're only going to notice one UEFI option, which is this Patriot memory. And what that is that's an external USB drive, and it's actually a UEFI bootable. But nothing else here is USB or UEFI bootable, which is fine. But the interesting part about this is that if you look through this BIOS, you're not going to find any options for NVMe boot. And the reason you're not going to find that is because that hardware doesn't exist as far as this motherboard was concerned when it was built. Okay, so how to boot NVMe on an old motherboard? Well, so my motherboard has EFI support, as you just saw, but as long as the device being booted is SATA, a CD, DVD, or USB, you're going to be just fine on that motherboard. Unfortunately, it was none of the above. So there's a product called Clover Bootloader, and it's often used by hobbyists, and it's normally used to build Hackintoshes. If you've ever run across it, that's more than likely the application you've seen for Clover. But Clover Bootloader is an open source bootloader that can chain to boot other devices, such as the 970 EVO installed in that PCI Express adapter card. And so that's what I did. So Clover Bootloader has a GitHub page. This is its GitHub page here. And I scrolled down on that page and did a quick screenshot of the basic features of Clover Bootloader. And you'll notice that you can boot Mac OS, Windows, and Linux in UEFI or in legacy mode. And it supports quite a few number of functions. So it's a really nice open source product to do this type of thing. So in installing Clover, basically you download the Clover ISO. I use Balena Etcher to flash a USB thumb drive with the ISO, which also makes it bootable. That's real typical of testing out operating systems, particularly if you're wanting to do things like flash an SD card for something like a Raspberry Pi. So Balena Etcher is real common, and it's available for Linux and Mac and Windows. So then I set the motherboard to UEFI boot from that USB drive I'd built that has Clover on it now. And that's why in that other screen you saw that that was UEFI bootable, because that was actually my instance of Clover. So you should see your boot options on the NVMe drive when Clover boots up. So Clover boots up, and again, this is one of those marvelous cell phone screenshots, camera shots. And you can't see it here because it got washed out. But this first thing here clearly says, and not in my picture, but it clearly says that it is the Windows boot option. The second one was the Ubuntu boot option. And then these third and fourth ones are also Windows boot options, but they're kind of bogus. I've been trying to remove them from the Clover menu, and I haven't been able to do that so far. I'll have to look into that later. But in any event, this is what happens. It comes up, and it also remembers the last booted operating system. So one of the pains on a dual boot machine with Ubuntu and Windows is the fact that, unfortunately, if you go to do a Windows update, many times it has to go through multiple reboots. And it'll turn around and unfortunately boot the default side, which is normally Ubuntu, and then you won't have finished your Windows update. This thing's real smart because if the last thing that you booted was Windows, it will continue to reboot Windows so it can handle those nasty multi-reboot situations for Windows. So here's a Pewter Room when I've actually booted it up after the clone and after using Clover. And I did a smart Control-I on the actual NVMe drive. And you can see here it calls out the Samsung SSD 970 EVO 1 terabyte. And again, you can see that it's Scott at Pewter Room. That's why we're booted into it. So then on that same machine, I bring up gparted. And in gparted, you can see how the dual boot machine works. I mean, the first partition on it is the EFI boot partition, which is always FAT32. The second partition, I forget exactly what this thing was. I don't think I need it anymore. I actually may be able to eliminate it later on. It's an ext4 partition. The next one is always this interesting little Microsoft Reserve partition that they set up that's usually real small, 16 megabytes in this case. It's a requirement. And then the next one is an NTFS partition that's also usually around 200 megabytes that they create as part of installing Windows 10. And then they have the real Windows partition. In this case, it's 848, or no, that's not the real Windows partition, 848 megabytes. So, sorry, the first one here, the 191 was the real NTFS partition. And then we have the 840 meg one, which is a small one. And then they always want, for some reason, a 1 megabyte unallocated space after the NTFS partition on the disk. It's just it's a Windows thing. And then my last partition here, and you can see it's locked. It's locked because it's mounted and we're booted into this Ubuntu instance, is the ext4 partition for Ubuntu, which is now at this point 641 gigabytes. So there you go. There's a drive map of how the new cloned NVMe drive looks. Okay, So I booted both Windows and Ubuntu through Clover. Worked just fine. Just have to leave the USB plugged in because it chains over to the NVMe drive. And here on the left-hand side, you're seeing an about in Windows, and it's basically saying, yep, here's this speedy AMD A8 5600K APU with Radeon HD graphics, 8 gigabytes of memory, and there it is, Win 10 Putter Room. I changed the name of it way back when that I made this dual boot because I wanted to realize when I looked on the network whether or not Ubuntu was booted or Windows was booted. So just a thing. And then over here on the right-hand side is the same about screen except for when we have Ubuntu booted. And you can see here it calls out the memory minus the graphics. Obviously, we have reserved memory out of main memory because we're running integrated graphics. And then it calls out the same processor. So that's all there is to that. So in summary, repurposing hardware is really cost effective in the Homelab. You can always find something that you can use from one of your machines to purpose into another machine. And then reusing the 970 EVO 1 terabyte NVMe was possible with Clover Boot Manager as a workaround. And cloning drives with DD is efficient and safe as long as the target drive has an equal or greater number of logical blocks. And DD is the Linux copy and convert command because unfortunately CC was being used by the C compiler, so they made the command DD. A little bit of trivia for you there. And Putter Room, the AMD A8 5600K, got a significant performance boot after this. Running it, everything is really great now. It seems like I breathed new life into it. Anyway, that's it for today. Thanks for listening, and please subscribe and like, and leave some comments too. And we'll see you next time.